So thanks for coming. I'm Matt Dowle. I'm the main author of the Data.Table package in R. So the title of the presentation is Data.Table and R in Insurance. My background isn't insurance. It's in finance at banks and hedge funds, equity market neutral data, cash equities, stocks and shares that you all know and recognize globally, high frequency tick data, and low-frequency fundamental data, analyst estimate data, that kind of thing. And so the largest amount of data I've dealt with is about 25 terabytes of tick data in financial markets. But today is speaking about insurance. So Data.Table is, well, because I'm the author of this package and people use it, an advantage is that I can call in some favors. So very kindly, two companies have allowed me to use their presentation on how they use Data.Table and present it to you. So Landmark is a company in the UK that use Data.Table for this analysis. So it's an insurance services company, and they fly a plane over every meter of the UK, and they point a radar gun down at the ground, and they measure the height of every point on the surface every meter. So that's the, let's see if my pointer works. You see that? You see the pointer on the screen? So that's the raw data that comes in, and the colors are just the height of the object at that point. So then this is a higher zoomed out image of this. So this is a landscape, and you can see the buildings. And I said to the chap, oh, you can see shadows on the buildings here. And he laughed, and he said, well, you can't do, can you? It's not a picture. The sun's not shining down on these buildings and creating a shadow. That's been added into the image afterwards to highlight the fact that it is a building. So that's the black, and then the white is missing data because that's water, and the radar doesn't bounce back from water. And then what can be done is all the buildings can be removed, and then you've got the topography data on the bottom right. So that's their starting data. Then they use statistics and machine learning to pull out the building outlines. They use this package in R, and this is just an example of R data. And then they do this. So they look at every rooftop in the UK, every dwelling. There's 60 million people in the UK and 20 million dwellings. And they look at the southwest facing slope and the northeast facing slope in this example with the red outline. And they're interested in calculating the slope because, and distinguishing, firstly, very simply, flat roofs are a higher insurance risk, more prone to leaks and build-up of snow and so on flat roofs. And a pitched roof is less risky. So that's simply what they're doing. Also, they're looking to see if there's any trees in the area, anything attached to the roof that might fall onto the roof and damage it. And they do that for every single roof in the UK. And there's some more R code that they're using. And then this is the kind of, the way that they calculate the slope is they order the height data across this area. So this is the road, and then it goes up to the roof, and then this is the roof line, and then it can measure the slope using these data points. So they've got to use some algorithm, machine learning to get those points. And this is the measurement data for a particular roof. So how are they doing this? They're using Data.Table, and this is the actual query that he's using in his system. There's nothing being removed here. So it's quite a large query. So how do we read this? Well, the Data.Table is called this object, and then there's no where clause here, so it's just comma, and then it's got a bunch of vectors that are being computed. And then at the end, there's this function roof orientation, which takes another bunch of column names. That returns a list of 13 columns. And then that's all done by building ID. So it's grouping by 20 million dwellings. And this only works in Data.Table really at this speed because of this feature of C, of a list of vectors with a list. And C in R of vectors with a list returns a list. And so you get however many columns there are here, let's say there's 15 or something, plus 13, so you get 28 columns as your result. You don't have to list out all your columns separately or construct the query. Data.Table will automatically do that and make it efficient. So that's running quickly, and he runs this every month to update the model. So that's one example. Let's check for time. Any questions so far? Nope. So that's his name and his title, and if you want any information about that, then contact him. So another example is here in San Francisco, the Cat Risk Company. It's their website. So they're doing again, topography information. It's written in R, using Data.Table for each. Let's find a chart. So they're looking at flood risk across the US, wind speed data, this kind of stuff. So this is all partly being done in Data.Table, in production, in companies. So I won't go into too much detail over all this data. I know you use Shiny there as well, I think. So again, Data.Table being used in insurance and production. And a final example is I went to a hackathon in London a few months ago, and it was a great day. What they did is they got a bunch of data scientists, doctors, and statisticians together in a room, split them up into teams. So I was in a team of 6 people, 2 data scientists, 2 doctors, and 2 statisticians. And they gave us this data. We had to do a ethics exam online before being allowed to look at this data, because this is real data from one particular ICU unit in a hospital in the States, not sure which one. And so it's real data with real doctor's notes on all the patients that come into the unit. So if we scroll down, there was, we had 2 days in the hackathon, and they provided it in an SAP HANA format, which everyone struggled with because nobody knew it, and it had some idiosyncrasies that weren't very well explained. So people wasted time on that, and then went to the SQL method of taking the text files, loading it up into SQL, and using Postgres mostly to do the analysis. But our team, because I'm the Data.Table guy, decided to use Data.Table. So I fired up a EC2 instance with 1/4 terabyte of RAM and just loaded the flat files into in Data.Table. So there were, I'll make it a bit smaller so you can see them. So you've got a bunch of flat files. All these numbers, ranges are patient IDs. So that's the same structure of data but split by ID and over a few years of data. So compressed, it's 3 gig, and uncompressed, 30 gig of data. Just looped F3 through, loaded it all up, and the tables that came in, some definition tables and mapping of patients, various qualities like height and weight. and waveform data. So everything that's measured in ICU is in this data set. So it's a messy data set with lots of missing data. And our task was to see if there's a paradox in the medical research literature that obese people who are admitted to ICU have a higher chance of success, of surviving. So this is a bit of a paradox and a bit worrying, because obviously we shouldn't all go out and eat a lot if we want to survive ICU. So it must be something else. So the natural theory is that maybe obese people are monitored more in ICU, and that's why they survive. So if so, which particular measurement are they measured more? And if so, then can we find out what that is and then do that, whatever's different for those patients, for the non-obese people, and then increase their chances of survival as well. So we had to try and work that out in about a day, when research academics have been spending months and months on this data. But we did a good job. We loaded it up and we got some interesting results. So it's all done in Data.Table. And the thing that surprised everybody at this hackathon was how easy it was to load data up into R, into a EC2 instance, which was costing 50 cents an hour for me. And it was quick because it was in memory. It wasn't like SQL where you're hitting disk on every query. The queries were quite straightforward, and we managed to do quite a lot. So that's kind of an insurance example, a health insurance example. So what is Data.Table then? What are these people using Data.Table for? Has anybody used fread in Data.Table? One, two? Quite a few people. So when people first start using R, they need to get data in, and the base R function is read CSV. It just takes ages because it's 30 to 60 seconds variable for a 50 megabyte file. And so you read the import manual, data import manual, and it says, well, you have to specify col classes, give it some hints over the column types, the number of rows, and then you do indeed speed it up to 10 seconds. But fread and Data.Table, you don't have to specify those extra arguments, and it's much faster. So it's 10 times faster than the worst case with plain read CSV, down to 3 seconds. So it's faster and it's friendlier because it's easier to use. 20 gig, then it's hours down to 8 minutes, and it's easier to use. So once the data's in, what do you want to do? Well, you want to do some aggregations on some columns. You want to see you don't know what the columns are yet. You don't know the qualities of those columns. You just want to play around with it and investigate the data. So let's do some benchmarks of grouping. So we're going to use, how many people have seen these benchmarks before? Because they're on GitHub. Oh, not many. One. Okay. So I get frustrated with benchmarks on Stack Overflow and online that take small data and loop it round thousands of times and report the mean and standard deviation on small data. It's got to be large data. It's got to be much larger than cache, L2 to L3 cache, which is 8 meg. So sometimes you see like a 10 meg example being used for benchmarking. It's totally inappropriate because it just fits in cache. So you're not testing page fetches from RAM to L2 cache. So it's got to be large in the first instance with different types of columns, large groups, small groups, that sort of thing. So this is the benchmark I think is quite reasonable. So 1 billion rows in R, 50 gig. This is quite routine. Running on an Amazon EC2 instance. So we do 2 runs. So the first time and the second time is reported. So you see the two bars here. And we've got 2 tests here. And we're comparing Data.Table to dplyr, so 2 R packages compared to pandas. And Data.Table's winning. So this is the first test is 100 large groups. And then test 2 is 10,000 medium-sized groups. This is the syntax, so they're all quite similar. Not much in it really in terms of syntax, straightforward. It's just summing mean of a column by another column. So data tables faster in those two cases. But when you have large number of small groups, then data table really shines. So dplyr is taking 14 minutes here and then 10 minutes on the second run, whereas data tables under 5 minutes, under 4 minutes. So it's fast at doing aggregations. So let's go to the limit of data table, which is 2 billion rows, 2 to the 31. We can increase that and go over the 2 billion limit, but we haven't done that yet. R allows us to. So when I did that, the first thing is pandas fails. It didn't work, so I reported that as a memory error, and they've fixed that now in pandas, and that'll be in the next version. So when that comes out, I'll update the benchmarks. And for 100 gig, 2 billion rows, dplyr is taking nearly 50 minutes, whereas data table is about 7. So significant difference. So the first example I showed with Landmark in the UK is actually doing this. They have 2 billion rows. They're pushing this limit, so they'd like the limit to be relaxed. And they have a lot of groups because they have 20 million dwellings in the UK. So this is realistic. Data tables used to win Kaggle competitions, and this was presented at USAR earlier this year. So that was really pleasing to see that being used. So far, we haven't really talked about equijoins, but it of course does equijoins and does them very quickly. Data.Table does 2 other types of joins that other packages don't do and are difficult to do in SQL. So one of them is overlapping range joins. So this is useful in genomics, where you have large and ordered data, and you're looking at sequences of chromosomes, and you want to see how they overlap. So you've got the query in red. So imagine this as 8 rows in your right table, and then the subject in blue. So imagine that as 1 row in your left table in SQL parlance. And we want to see which of the red ones overlap with the blue ones. The crosses mean that they don't. You actually want to see which of the red intervals fall within the blue range. And it's important in genomics whether the ranges snap on the left, whether they're equal on the left. So this one's equal on the left, this one's equal on the right, Q4 is equal on the left and the right, and Q2 is completely within. And so that was implemented by my colleague Arun, who's finishing his PhD in Germany at the moment. So we presented this together at Earl in London a few weeks ago. This is his presentation. Those are the overlaps we've just seen. This is how we do it, by using the fast sorting in Data.Table and rolling joins to the prevailing observation, which I'll show in a second. So it's a really quick algorithm, and it took quite a long time to design and write. It's all entirely in C. Most of Data.Table is entirely in C. And it's very simple syntax. That's how you run the join. It's called F overlaps. Most of our functions start with F for fast, and works on many types. And in terms of speed, this is done by the bioconductor package, genomic ranges, but it's much faster in Data.Table. So 16 minutes down to 2 for this example. But a different realistic example, which Arun has in his real research with 7,500 scaffolds, currently takes 28 hours in genomic ranges, down to, well, they do that in parallel at the moment, and that parallel brings it down to 2 hours, but in Data.Table, without going parallel, it's just 4 minutes. So that's overlap joins, which is a different, unique type of join to Data.Table. Rolling joins I mentioned. I have to go really quickly because I've got about 8 minutes. So let's go to slide 57. So just quickly, what's a rolling join? This is from my background, which is finance data. So we've got IDs, symbols, and dates from 2008. And we've got 8 different queries. So here's the price data table. We set the key by ID and date, and it just sorts it. And then we join to Sainsbury's, and that's all 3 rows. 2nd of May is the 2nd of May, so that's 391 spot 50. The 5th of May is a gap, doesn't exist. So that would be an NA returned in SQL. And it's an NA returned here in Data.Table as well. But if we pass roll equals true, we say roll the prevailing observation forwards. Well, the prevailing observation on the 5th of May in this gap is the one before, which is the 2nd of May. So we roll the 391 spot 50 forwards, and that's the answer. 1st of June is a month after the end of the last observation for Sainsbury's. So we'll roll that forward, but we won't roll the ends. So if we want to only roll if it's in the middle of the time series. So if it's stock flat lines, we don't want to return a flat line at the end. You just pass roll ends equals false. And then what I needed when I was looking at analyst data was I wanted the current analyst estimate, provided it was updated within 20 days. If it was more than 20 days, I'd consider it stale. I don't want to use that data. You just change roll to 20, and that won't return the 6th of May, because the 6th of May is more than 20 days before the 1st of June. So NA is returned. If we increase the window of staleness we're happy with to 40 days, then the 389 is returned because that's within 40 days ago. So we're doing that in Data.Table because we sort the data. We've got very fast sorting. There's no comparison sort. It's all radix sorting, and we don't hash. dplyr and pandas hash the data. So it's not sorted, so it's difficult, and it's difficult syntax, so you can't do this very easily, and it's not as quick. And it turns out that even if we sort the data, we can do equijoins faster than hashing as well. Hashing is the wrong choice. dplyr and pandas have got it wrong. Hashing is the wrong choice, and Data.Table got it right. It's just that we took a while to get the implementation fast that scales. So we do fast radix sorting without any range restrictions for float, character, and integer. And it's blisteringly fast, and it took several months of development time in pure C to get that right. So why am I here at a H2O conference? Because there's several things we'd like to do with Data.Table, like making it parallel and scaling across multiple clusters and so on. And H2O have already done that. So maybe H2O have superseded Data.Table. So that's what I'm worried about, and I had a look. So yesterday I started playing with H2O, and it's great. So I started I'm going to show how easy it is to start an EC2 cluster, EC2 instance, spot instance for 50 cents an hour. So I've got, and I want to test 2 things. The speed of fread versus H2O's file importer, because H2O's file importer is parallel. So on 32 cores, it should be much faster than fread, because fread is just single-threaded. And the second thing is just grouping to see how fast dplyr is versus Data.Table's grouping. So we start up an instance, we set the CRAN mirror, we install base R, we install curl, we install, so it's just a fresh, blank Unix machine. We install Java with those commands, htop so we can see the performance of all the 32 cores. We change the default compilation for R packages from 02 to 03 and take away the G debugging symbol. We set the repo, we install Data.Table, 3 packages that H2O depend on, then H2O latest release, and we quit R. So that's installed. It takes about a minute or two. And then this is the test I ran. So I had a great time in the hacking room yesterday, experimenting and putting this together. So this is on the, can everyone see the text, by the way? Yeah? Does it come up? Oh. Well, I'm out of time anyway, so I've no time to sort that out. You just have to believe me and sort of see some of the text. What if I move it? No, I can't, I won't. Is somebody else due on after this, or shall I just keep on going until they stop? Okay. Okay, so you require data table N, so we'll do 1 million rows, K100 to create 100 groups of large groups, 9 columns. So this is the same data that we saw I presented earlier in the benchmarks, and we create some data, write it out, write this million rows out to a file with the column names and then without the column names. ln-s is a trick that Cliff showed me yesterday to create a big file quickly. Count them all together, that's our test file. So it's a 22 gigabyte file, 500 million rows. Then all we do, start R, require H2O, H2O server init, and that automatically creates the cluster of CPUs. Import file, takes 52 seconds. Create a function of summing the V1 column. Add that function to the server, which apparently looks at the parse tree of the R and optimizes it in the H2O space. And then we run the H2O.ddply function, which takes 75 seconds. And then we run it again and to check that timing at 69 seconds. And I saw all 32 cores light up. It's doing its job. Have a look at the answer. It's 100 rows by 2-column answer. Let's try in data table. So here's the same file. So it's 315 seconds to load the test CSV. That's 6 times slower than, or rather, H2O is 6 times faster. So that's a great speed up. I would have expected more like 30 times faster because it's on 30 cores. But there's other things going on inside H2O in terms of the blocking and things like that. But that suggests to me that maybe I could speed up H2O's file loader maybe a little bit by maybe using some of the tricks in fread and putting that into H2O. So that's something I would really like to do. And then we do the grouping. And grouping in data table takes 14 seconds. Well, and then run it again, 14 seconds again. Oh, hang on. 14 seconds is faster than H2O on 32 cores. How can that be? So there seems that there's a wrinkle here and something's going wrong. So Cliff's had a look and can't see anything immediately wrong with this. But you know, I only started yesterday. It's the first test. So I think the message here is it's really easy to get going. And now we just need to work together and look at the profiling and find out where the wrinkle is. But I'm more than positive that the H2O is the right environment to do that in Java, and that there'll be a wrinkle somewhere to sort out and speed that up. But at the moment, data table on a single core is 5 times faster than H2O on 32 cores in this test. And then they're identical results. And that was it on H2O. So I'm convinced that the way they're doing it in Java makes a lot of sense. Because if I tried to parallelize fread in the way that I'm doing it in C at the moment, I'm not sure how that's possible, because OpenMP could create multiple threads, but R isn't thread safe. So if you're trying to add to R's global cache from within a thread in FRead, it's not going to work. So they've done that. They've just avoided that problem by not using R. They've just used it, gone to Java straight away. So that seems to be the right thing to do. What else? I think that's pretty much it. I spoke at the Bay Area R user group when I landed on Monday, which Joe over there runs. So that was great to meet our users, and I went through some timings of ordering. So I haven't got time to actually show this. I could if anybody wants. But on 40 million random floats, Data.Table takes 17 seconds to sort them, and base takes 7 minutes. So it's massively faster, and it sorts in linear time. It's less than order n log n time. And that's how we're able to now, in the latest version, add secondary indexes. So you don't need to set key. Equals equals works in I. And so I did some tests of basically, if you run ID equals equals ABC, the first time, it'll create an index and then use it. And that's the same speed as equals equals in dplyr and baseR. And then the second time it's instant because it uses the key. So it's an easier way to use Data.Table. You don't have to set key first. You don't need to reorder the data. It was never the sorting that took the time. It was never the finding the order of the rows taking the time, rather. It was the act of then reordering all the rows, and that no longer needs to be done. But if you use, people often ask, can you use dplyr syntax on a data table? Yes, you can. And does it use the automatic index? Yes, it does. So you don't have to, as long as you pass a data table to dplyr, the percent greater than percent space filter, ID equals equals ABC, will get passed through to Data.Table, and it'll use the secondary index to look it up instantly. So that's in 194 on CRAN. There were a few wrinkles with automatic indexing, so you had to turn it off as a new feature if you hit those, and those have been fixed in 195, which will be released as 196 soon. And then just there's lots of FRead fixes in the latest version, and it sort of looks after you. Data.Table's always looked after you in terms of numeric rounding, so you can do equals equals on floats, so you don't have to do an absolute less than epsilon on numeric data, so it's easy in that sense. And finally, my status is that I'm not working at the moment, haven't been for a year. I've been working on Data.Table and taking a year off. So all this work's been a lot of work, and I've done it for free, and I can't do that anymore because it's taking too long, and I'm not earning any money. So that has to stop. One thing I've done is with Arun is we've jointly done a data camp course. So we had fun going to Belgium and filming that. It's me and Arun on screen with Data.Table slides, 30 minutes of video, and then it's split into 10 sections with exercises that you do in the data camp environment. And that's 95 euros, $125. And so it's much cheaper than in-house in a face-to-face course. So please buy that. And there's a Data.Table coupon which gives you 10% off if you'd like. I do consulting, and I have a support contract with a big fund manager in London which uses Data.Table to manage their money. So that's another option. But currently it's not enough to support myself, so I'll have to think about what to do next. When you're asking questions on Stack Overflow and writing quick blog posts, picking up these little problems, just have a heart for the developers who actually do it in their spare time, in the middle of the night, at weekends, and We're just human, and it's tough. And my wife's not very happy with me at the moment after doing this for a year and not earning any money. So, so I'm here in San Francisco because this is a place to be, isn't it? Isn't it? I was told that I could get off the plane and I'd get $1 million investment just like that. Hasn't happened yet. So if you have any contacts, any ideas of what I should do next, should I carry on doing open source? Or should I just forget it and go into closed source? Are you going to buy the Data Camp course? Because I need you to, otherwise I can't support myself. Or do you know companies that will pay for support? So the way I've structured the support with the contract I have is it's up to half a day support from me per month. If in a quarter they don't use that support, then I'll go in and give a presentation on all the new features and bug fixes that I've been doing to keep the relationship going and to bring them up to speed with the latest stuff, because it is difficult to keep up to speed with all the changes that go on. So I think that's a good arrangement, because then you get something for your support contract. It's not just something that you have there for a whole year and never get anything for it. So I think that's a good business model. So I'm interested in your feedback on that. And the homepage is there on GitHub, on the wiki. Everything's in one place on the wiki, and all the presentations and that's it. Yep. Thank you. Any questions?
I got a mic right here.
So I'm looking at the use case of using it for time series data.
Yeah.
So time series data and doing the moving window statistical analysis on that.
Yeah.
Is that something which is supported in that?
Yeah, you use the rolling functions in other packages inside Data.Table. So the idea of Data.Table was, first of all, people say, well, which time series class should I use? Well, the idea was it doesn't matter to us which one you use, it's just ordered data. So you can use any of them. I sometimes use integers and just YYYMMDD stored as an integer, or use an epoch-based date. So that's that's the philosophy of Data.Table, is not to do everything in Data.Table. That's quite different to Pandas, where they pack everything, all the plotting and all the function. It's just a very, very big package. Data.Table just does a few things very well in terms of sorting, doesn't do hashing, and the sorting is for time series to get the time series ordered and contiguous in RAM, so that it's, when you're moving through, it's in cache, minimizing RAM to L2 page fetches, and then you use other packages with it. So use the rolling functions in other packages.
Thank you.
Yeah. Any more? Yep.
Do you think Data.Table will ever make its way into base R and replace data frame?
Do I think...
just to repeat, do you think Data.Table will ever make its way into R base and replace data frame?
There's two things about Data.Table. There's the syntax change, because I wanted to put inside square brackets the I, j, and by, because I wanted to use column names as variables. And there's quite a bit in presentations about that. I just find that very natural. I don't want to be typing df, open bracket, df, dollar, df, dollar, df, dollar, to be able to get to those column names. So that will never make it into base, because that would break base, and packages would depend on base. So Data.Table changes that syntax, but inherits from data frame. So any packages which use data frame syntax, when Data.Table gets called, the square bracket method for Data.Table, it looks to see where it's called from, and if it's called from a package which uses data frame, which doesn't know about Data.Table, then it reverts back to the base R method, and that's how it's compatible. So that won't. But in terms of the speed things, 4 years ago we brought in : equals to do update by reference, because updating one element of a data frame copied the whole entire data frame. So that was cripplingly slow and prevented a lot of activity and pushed quite a few people off to Python because of that, I think, over those years. And that has made it into R now, and not in the way that I've done it, but it's a shallow copy of the columns, so that's much faster. So it's catching up. So those things, the syntax not changed, but it's faster. Sorting definitely could be. That could be put into base. fread certainly could be. The only reason it's a separate function is because it's hard to make it fast and be a complete drop-in replacement for read CSV because there's so many cases. So in the meantime, we've created fread to do the best we can. We've fixed all the bugs. And then over time, eventually, hopefully, it will become a complete drop-in replacement and then could make it into base and then replace read CSV. But in the meantime, you can just overload read CSV, so at least, and to use fread, so at least in your own code, you could have a drop-in replacement. There aren't many packages which use read CSV themselves. What else? Joins, maybe merge and base could be sped up using data. There's quite a bit of stuff that could make it into base. Certainly sorting. Sorting's the main one. Our radix sorting could make it into base. That would be really nice. But it's a syntax. I'll still be using Data.Table even if it does, because I want to type quick statements at the prompt and in production code, lots and lots and lots of queries in a short, compact, sequential fashion. I don't like using lots and lots of SQL big statements because it just ends up with loads and loads of code and you're repeating yourself over and over again. So I'll be using Data.Table syntax with putting the 3 arguments, I, j, and by, inside square brackets. It's one method which sees those 3 arguments before evaluation, and then that enables it to optimize those 3 elements. And it's in R because R uniquely has lazy evaluation, so that's why it's not in Python and not in Julia, because neither of those have lazy evaluation. Long answer to a short question.
So I have a question for you about what you were doing with H2O yesterday. So having looked at some of the code, is it the kind of project that you plan on contributing to?
Can you speak up?
Sorry. Is H2O the kind of project you plan on contributing to after your experiences with it in yesterday, the coding?
Not for free.
Not for free, okay.
I think I've done enough for free for 6 years now.
Have you compared Julia versus Data.Table? Like,
sorry, I can't.
Have you compared Julia features, the same features that Data.Table provides versus Julia's? Julia?
Yeah, compare the features of Data.Table to Julia?
No, the read CSV features from Julia.
What about them?
Have you compared Data.Table with those?
Have I compared
like fread? Yeah, fread.
So have I compared fread in Data.Table to Julia's file reader? No, I haven't, but I have heard from the people who know about it and want. This was about 6 months ago. They asked if they could take fread, or if I wanted to make fread, because it's slow in Julia. Their file reader is very slow, apparently, or relative to fread anyway. I don't know if they've improved it since then, but I'm sure that Julia as well, they'll get there. I'm sure they'll, because it seems to be a bit more designed for more natural parallel processing, distributing, and so on. So they might get to parallelize it quicker, but H2O is already there. But I think there's another thing to fread, is that how user-friendly it is and flexible. So one of the things it does is it jumps in the middle of the file to work out the column types for you. Our users tend to have an amazing variety of different types of sparse files with types that look like integer to begin with and then turn out to be character later on and so on. Survey data is a nightmare with carriage returns. That hospital data had doctor's notes in it, which were huge, long paragraphs split over multiple lines, along with short columns and things. It detects all those types and it jumps into the middle to look at the types in the middle, and then looks at the types at the end as well. And in 195, that's much more stable in terms of if it lands inside a unescaped quoted subregion of a quoted field containing new lines as well and things like that. So it'll keep on going to the first new line and then test to see how many fields it has after that to get a consistent number of rows and work all that. Because it's important to get your type absolutely right up front so that you allocate your column with the right type, fill it in straight away with the right type. So FRead does a lot of things like that which don't come up in the benchmarks because we don't tend to generate, it's hard to generate a benchmark which is really sparse, large, and has a column like that. So it does, there's a lot of convenience things. In FRead you can skip to, you can have several tables in the file. Not many people know that you can have 10 tables in a single file. In FRead you can set the auto start to be anywhere within one of those tables, and it's a little bit like Excel when you do a pivot table and you click in the middle, it'll find the extent of the table and load that in. So that can occur in real life. Headers are automatically detected and removed, and people say, oh, well, I can just set skip to be 10 to go to where the column names are in the file. FRead does that automatically because users have a set of 1,000 files and the header varies in height in each of the files. So if you automatically detect where the column names are, then it's much easier. And then something FRead could do is, because quite often, like in the Mimic2 ICU data, there were a lot of files, and what I did is load them individually up using FRead and then Arbine list them in memory. So that uses twice as much memory as you should need. So FRead could go through 1,000 files, count the number of rows in all the files first, make sure they're all conformant before even starting to read the data, then allocate one single table, then fill it in across all the files. There's loads in FRead that I'm not sure people are really aware of that needs to be compared properly. It's not just speed, but features and convenience and correctness. And now that when FRead became available, people started using it and comparing it to read CSV in base and found some bugs. So the one I remember is long lines that could wrap round, and you'd get, so if you had 100 rows in the file, read CSV could read actually 150 because it would automatically fill silently and wrap around a line. So that was fixed because FRead highlighted that was an issue. I've forgotten what your question was now. Oh, compared to Julia, yeah. What do you think of Julia? Did you want to answer?
Yeah, I've just started using it. That's why I was curious
Okay.
how it works compared to this.
Well, if somebody wants to pay me to put it into Julia, I will. Okay, great, thank you.